Hi class, in this lesson we're going to mostly be working with the distributive property, but officially the lesson title is Properties of Real Numbers. We're going to be looking at other properties, but the primary one that you're going to be having assignments based on is this property here. The distributive property applies when you have parentheses and a number out in front. Now, I know these parentheses all have just two numbers in them, but they could have more. And what's happening is this 2 out in front has multiplication between it and the parentheses. So what we're supposed to do is take this 2 and times it by the x and the 4. So what this turns out to be is 2x plus 2 times 4. Now, 2 times x is just 2x, and then 2 times 4 is 8. So the solution, or the simplified version, is 2x plus 8. So let's try the next one. We've got 3 times x plus y, so we times it by the x and the y, so we'll get 3x plus 3y. And that's as far as we need to go. Now we'll learn in a little bit about like terms, but we can't add these because the first one's an x and the second one's a y. Okay. Now in this next one, we're going to distribute a negative 4. And we multiply the negative 4 times the 3x and times the 4. And that's going to give us negative 4 times 3x plus negative 4 times 4. Now I wrote it out like that just so that we can think through the actual multiplication process. Negative 4 times 3 should give me negative 12, and then I just bring the x and put it right down next to it. And then we have negative 4 times negative 4, or times positive 4, and that should give me plus a negative 16. I could also have just written minus 16, and that would be the easier way to write it. Okay. Now the biggest mistake that I see with students is that they continue and go ahead and try to make that into a 28x. Now we have to stop here because this one has an x and this one does not, so that's not like terms. Again, we'll talk more about that in a minute. In this last problem, there's just a negative sign out in front, and it needs to be distributed. Technically, when it's a negative sign, it's really a negative 1 that needs to be distributed to the negative 2x and to the 3. So it's going to be negative 1 times negative 2x, I can put parentheses around it, plus negative 1 times 3. And if I simplify, this first part should give me negative times negative, which is going to give me positive 2x, and then this is going to be a negative 3. So that's as far as I need to go with that problem. You're going to get some homework assignments that tell you to use the distributive property with a problem like this one. And you're not seeing problems that look like the ones we just did over here, where we were taking a number out in front and distributing it in. These problems were actually assuming that you went and did that already. We want to, there's two ways you can do it. You can actually pull this back out, and notice they both have it, so I can put it back out in front like this, where it's 58 minus 8. It's really the easier way to do it. Notice if I rewrote it, this is what I could have started with, where I had 3 halves times 58 minus 8. It could be distributed. If I distribute it, I would get what the problem started with. Okay, so that's why I say the reverse distributive property. Now that I've written it like this and pulled that 3 halves back out, technically that's called factoring, by the way. We'll learn more about that later. I want to go ahead and do it this way so I can take care of the parentheses. 58 minus 8 should give me 50, so I could rewrite that to be 3 halves times 50. And that's nice because the 50 is really over a 1, and I can take the 2 and the 50 and reduce to be 25. So all I really have to do is 3 times 25, which is 75. Okay. Otherwise, up top, the way that it was written originally, I could have also reduced these fractions. The 8 could reduce with the 2, the 58 could reduce with the 2, and then I could simplify from there. So, again, the answer is 75. I'll reduce it the other way also. So, you don't actually have to use the distributive property when they tell you to in the lab. What I could do is reduce the 58, in other words, divide it by 2, and that should give me 29. If I cross out the 2 and make it a 1, the 8 should turn into a 4, and then the 2 should turn into a 1. So really I'm left with 29 times 3 minus 4 times 3. Okay, and if I go ahead and multiply these together and then subtract, I'll end up with 75 again. So either way, you get the same answer. Now, just for your reference, these are the properties of addition and multiplication. Maybe you've heard of them before. The commutative property. Okay, this is where things are commuting. In other words, they're moving around. Notice in the addition side, we've got A plus B, and on the other side, it's equal to B plus A. In other words, they just traded places, and they're commuting. They're moving. If you're commuting to campus, you're driving to campus. Okay, so multiplication, same thing. It's the thing, they're just multiplied next to each other, and then they got moved to trade places. Okay, associative is this property where we change grouping. You're associating different groups. It's just the same way we would associate with different groups and mingle. Okay, so you're associating with different people. So I've got A plus B is being grouped together first, and in the second time, B plus C is being grouped together. And what we're saying is here, it doesn't matter if you group and add the first two or group and add the second two first, you get the same sum at the end. In the same way with multiplication, it doesn't matter if you multiply the first two and then the last one, or the last two and then the first one. Okay, so it's associating, in other words, you're grouping parentheses. Okay, you're not going to see any problems that actually ask you about these, so I'm not going to spend any more time dealing with it. There is the identity property and the inverse properties that we should be aware of. Identity for addition is if I'm adding 0, or 0 plus a number, and you get the number, that's the identity for addition. Same thing, identity for multiplication is you're timesing by 1. Anything times 1 gives you whatever the number was. Now inverse for multiplication, the multiplicative inverse is if I have a number like 2, its additive inverse, is negative 2. In other words, 2 plus negative 2 is 0. So whatever number, whatever the opposite of a number is, that's its additive inverse. Now multiplicative inverse is if I take a number like 2, I need 1 over 2. It's whatever causes it to cancel to be 1. Okay, so that's inverse. That's the inverse property. Okay, so whatever the number is for multiplication, if you just flip it over, so in other words, if I had 3, its inverse would be 1 over 3. Okay. Now the whole point of actually seeing those identity or properties is so that we can use them in simple addition. Now what we're getting used to now is what like terms are. Like terms are things that have the same variable with the same amount of exponent. In other words, this is an m to the first, this one is also an m to the first power. So they're like terms, and so I can add them and count how many I have. I have 12 here, I have another 1, so in all I have 13 m's. Okay? And so you could hear how I said m's. In other words, it's an amount of m. Okay, the first one had 12. The second one, there's always an imaginary 1 if the number's not written there. So in all I have 13 of them. Okay, if you asked a young person, a child, and you say how many y's are here, and you didn't have the plus sign, they'd probably tell you there's 2. There's 2 y's you're looking at, and that's the same answer we're looking for. There's one in front. There's a number 1 in front of there. There's number 1 in front here. What we want to do is add those numbers to get the 2. Is the algebraic way of looking at it. So it's 2 y's. Okay. Now this time we're going to understand that there aren't like terms. The m and the n are different variables. Doesn't matter what their exponents are, they're just different letters. And so there's no simplifying between the two of them. I don't take m and subtract the 5. Instead, the only thing I can do here is take my negative sign and distribute it. So that's going to give me negative m and then negative times negative 5n. Now, whenever you have a negative times a negative, it should turn to a positive. So the final answer is negative m plus 5n. Now for a quick example of the associative property, if I was to group this 5 and the 7 and add them first, I should get 12. If I take the 12 and add the 2 then, I should get 14. Okay? Now the same will hold true if I group the second 2 first and do 7 plus 2 to get 9, and then add the 5. That will give me 14. So this is just a quick example of how the associative property works and how addition doesn't have to be just left to right. Addition doesn't matter which way you go ahead and combine things. In the same way, multiplication doesn't matter. If I group the first 2, the 5 and the 7, and multiply them, I should get 35. And then if I times that by 2, I should get 70. Okay? Now in the second problem, if I group the 7 and the 2 first and get 14, and then times it by 5, I should also get 70. So again, multiplication doesn't matter which way you group it, just like addition. Okay, now to continue to use our properties, we're going to run into problems that have some that are like terms and some that aren't. And in this case, we've got m's, and then we've got constants. Okay. Now, what I want to do is combine them separately. So I'm going to put a triangle around my m's to highlight the fact that those all go together, and then I have the circles around the constants so that they go together. Okay, so I've got negative 2m's, I've got 5m's, and I've got negative 6m's. So I combine that all together. I really, in my head, I'm actually working through what's negative 2 plus 5 minus 6, and then whatever that outcome is, I'll put it next to an m. Okay, so negative 2 plus 5 would give me 3, and then minus the 6 would give me negative 3. So negative 3m is how many m's I have, and then I combine my 3 and 8 to get plus 11. So the final outcome here will be negative 3m plus 11. Now again, I wouldn't exactly go the route I just showed you to work through this. Here's something more like what I would work. So I would usually just do the negative 2 and the 5 to get 3m, and then go ahead and do these 3 and 8 to get my 11, and then I just go ahead and bring down my negative 6m. So I would kind of work it down vertically like this, and then I'd go ahead and combine my negative 3m and my 6m to get negative 3m plus 11. Again, I'm just working with the coefficients, which are the numbers in front of the variables, to actually do the subtraction. It's having 3m's, you're losing 6, so in all you have negative 3 left, is another way you can think through that. Okay, now in this situation, these are all y's, so they are all like terms. Okay, because they all have y's. So what we need to do is just worry about the numbers and to figure out the final amount of how many y's I have. So again, the outcome is just going to have a y in it, and I just have to do the math with the numbers in front. So 5 minus 8 minus 6 plus 11. Okay, and so if you work through that the way that I do, I don't, again, write it like that usually. I start off and I do 5 minus 8, and I get negative 3y. And then I take my negative 6, and that gives me negative 9y's. And now I take my negative 9 and I add my 11y. And then I get my final outcome of 2y's. That's how I usually work through it. If you want to pull all the numbers out in front, you can do it that way also. So now let's take a look at a more complicated problem that requires distributing. The first thing I want to identify is that I have a negative 5 that needs to be distributed into the parentheses. So that's actually where you need to start. For PEMDAS, it says parentheses, then multiplication. So I go ahead and distribute the negative 5, and that's going to give me negative 5x minus 5. And then I go ahead and bring everything else down. So I got my 3x plus my 4, and then minus my 8. And then I want to go through and highlight what my like terms are. Well, I have a 3x, and then I have a negative 5x. Those are like terms. And then left, I have 4, negative 5, and negative 8 that are constants. Those are also like terms. They're numbers that need to be added separately. So let's take care of my 3x and my negative 5x. If I combine those, I should get negative 2x's. And then I need to work through, I have 4 minus 5. That should give me negative 1. And then I have minus 8. So I just simplify, finally, my negative 1 and my negative 8 to give me my final answer of negative 2x minus 9. Where my negative 1 and negative 8 gave me the 9. Okay, so now let's take a look at this problem. Often I have students that distribute this 8 and try to distribute it into the parentheses. Well, what's actually supposed to be happening is I've got this negative sign that needs to be distributed, and it alone gets distributed. This 8 stays out in front. So I distribute the negative sign, and that gives me negative 3m minus 2. And then out in front is still your 8. Now, to finish, you just combine your 8 and your negative 2 to give you negative 3m plus 6. Okay. Now let me show you a similar problem, and you can see where people run into more issues. If I had 8 minus 2 times 3m plus 2, what students often do is they combine the 8 and the 2 to make 6, and they'll rewrite it to be 6 times 3m plus 2. Now, this is wrong because you're not following PEMDAS. PEMDAS says you need to do the multiplication first, which is actually going to cause me to distribute rather than do the subtraction to get the 6. So really, really, really watch out for this mistake right here. Okay? So now, to do this correctly, what I should do is take my negative 2, distribute it, and it'll give me 8 minus 6m minus 4. And then the other thing that, let me pause here a second, as people make mistakes is they'll leave the plus sign right there rather than multiply negative 2 times positive 2 to get my negative 4 like I should. Okay? And so to finish the problem that I made here, we should have negative 6m, and I should combine my 8 minus my 4 to get positive 4. And that would be your final answer there. Now let's look at a problem where we've got numbers and variables getting all multiplied together. Now notice I got 3x, it's being times by the 5, which is being times by the y. Well, the way we deal with this is the numbers get multiplied separately, 3 times the 5, and the variables get kind of pushed to the back, and usually in alphabetical order, x, y, z. And to finish, all we have to do is multiply the 3 times the 5 to get 15, and then you just write x, y. There's nothing you can do with the x, y other than put them next to each other, because we don't know what they are. So this would be your final solution here.